So then we do a series of things, right? So this 606 watts per square meter is shining on the upper atmosphere of the planet, but then we have to deal with the reflectivity of the upper atmosphere, right? Okay, so 23% of the light is going to just reflect off into space. Okay, otherwise, if nothing reflected into space, we couldn't see the planet. All right, so what portion of the light makes it to the surface? Well, it's going to be 606.0735 watts per square meter, right? Times 1 minus 0.23, right? Remember, this is 23% is reflected into space, and it wouldn't kill me to do this. Is it 77%? 100 minus 23. That's 70. 77% is absorbed, right? I'm too lazy to actually, calculate that, right? So I'm going to take that number, that's 606, and I'm going to go times parentheses 1 minus 0.23, because this is how you do albedo, right? And I get that this is 466.67 watts per square meter makes it through the atmosphere, right? Right? So we got our right answer here, right? All right. So now let's look at the next thing, right? So now we've got that 466.67 watts makes it through the atmosphere, right? Then it says, what is the average intensity of light over the whole surface of the planet, right? Well, this gets to be, it's like, well, because here's my planet, right? Here's my sun, right? And this part of the planet is light, and this part is dark. Okay, so is that half of the area? Well, not really, because think about how faint the light gets near the poles. It's a grazing angle, so it's like, it's actually not all that tough. Okay, if you're standing here at this star and you look at the Earth looks like a circle, right? Okay, so the Earth is actually pi r squared is the area that we absorb through, right? If you just look at the Earth head on, it just looks like a circle, right? Okay, but pi r squared is being spread out over 4 pi r squared is the actual area of the Earth. Okay, so let me just say that again, right? If you look at the Earth from the sun, you just see a circle. So this is the absorptive area. We are absorbing pi r squared, right? But the Earth is actually a sphere, and so this pi r squared is being spread out over a sphere. Now, what's the ratio of the circle to the sphere? Well, it's exactly 1/4, right? Okay, so pi r squared, the area that we absorbed from, right, is distributed over 4 pi r squared, right? So notice that it's 1/4, right? So how do we do this? It's 466.67 was the watts per square meter that made it through the atmosphere times 1/4. That's fun, huh? So divided by 4, and I get 116.669. And that's watts per square meter average on the Earth. Is this a valid calculation? I don't know. I think it is. I think it's pretty good. All right. So let's look at the next thing.